Fabulous. Thank you so much. Okay, so as you all can tell, that I'm sitting in my office here at the Goddard Space Flight Center with my deputy project scientist on Artemis 3, Dr. Patty Boyd. Before we get into the meat of the content, I just want to take a second to reflect on sort of an interesting thing that happened to me last night when I was walking the dog and looking up at the moon, as I always do. And yesterday, a series of storms came through DC, some very low, dark clouds, and there was a beautiful quarter moon out, and my view of the moon was obstructed, and I was really upset about that because I love looking at the moon and thinking of all of my friends and coworkers who are looking at the moon with me as well. And I'm walking the dog there, and I'm thinking, boy, I hope Barbara's looking at the moon right now as well. And eventually the storm clouds cleared out, and we got a great, beautiful view of the moon as the sun set last night. And I hope everybody takes some opportunity to go out and look at some clear skies and go look at the moon in the clear skies tonight, wherever you are. That's one thing that as a community we can do, because storms will pass, skies will clear, and the moon will remain. I'm so delighted to be joined not only physically here today in my office with Patty, but also here on Artemis 3 as my deputy project scientist on the mission. And so if we can go to the next slide, I'd like Patty to take a few minutes to introduce herself to this community, because she's going to be part of this incredible journey that we're on together. She's going to be helping me pull this mission off and pull the entire SMD science team together as we try to make history together. So next slide, and I'll turn the ball over to Patty.
Thank you, Noah. I am delighted to be here and also very, very humbled. I love your story about looking up the moon, because I think we're probably in a group of hundreds of people who do that as often as they possibly can and remember doing it from maybe their very first and earliest memory. I'm one of those people. Can you please go to the slide, which I'm calling my meandering path through NASA? Noah asked me to give a little bit of background of where I've been at NASA and bringing me into Artemis. I'm happy to do that. I'm going to do it quickly. But I started at NASA Goddard, fresh out of grad school, to come work on a first generation Hubble Space Telescope instrument. I think it was peak NASA to be part of a mission that involved pushing our scientific capabilities to their limits by involving humans working in space on cutting edge hardware. My second image there is of an astronaut putting CoStar onto Hubble. That happened very early in my time here at Goddard, and that instrument replaced my instrument, the high-speed photometer. So I wandered into X-ray astronomy. I studied time variability for looking at geometry and dynamics, so that translates well to other wavelengths. I worked on XTE and SWIFT, smaller missions. SWIFT in particular chases gamma ray bursts, autonomously points and changes the science timeline daily, so there's a constant combination of new science and planned science. Also ran the guest observer programs and the education and public outreach for both of those missions. Went to headquarters on a detour, very exciting detour, to be the program scientist on the Kepler mission, NASA's first exoplanet mission. I was the program scientist in the year before launch and through commissioning, and the year post-launch. Came back to Goddard just in time for the 25th anniversary celebration of Hubble. Became part of the Hubble team again. That was wonderful to be back. Also got involved in management of projects and people. Got very involved in cross-divisional exoplanet studies here at Goddard. Goddard has a group of folks that work together across Earth, Helio, planetary and astro, to think of exoplanets as places. Got involved with the TESS mission. I was the project scientist for that mission. About the same time, led a PRISM proposal for a payload on the moon called Earthshine. We were not selected, but the paper is out there in JADIS. There's a link at the bottom. We believe that this will get done, studying Earth as an exoplanet proxy for the moon. It's just a question of who and when, so the paper is out there with all of our details. We are very collaborative and open about sharing what we would like to do. I think this is really a community thing that should get done. I spent a little bit of time most recently at NASA headquarters to start a brand new program called Mosaics, and its goal is to fund new partnerships with NASA scientists and faculty and students at smaller institutions. That program is now created and well underway. We're currently funding more than 50 teams, some of them even doing some science that is related to Artemis, so that's very exciting. And just recently saw the opportunity to join the Artemis 3 project science team. So I am delighted to have been selected. I am very much a team player, team person. I am very committed to collaborative science, open data, and I am here to help, and I really appreciate the opportunity. Thank you.
And in Patty's last slide here, part of her experience, if we go to the next slide, is working with multiple partners on tests, including SpaceX.
Yep.
And so you're going to talk a little bit about that experience getting tests into space.
Sure. I mean, so TESS launched in 2018. It was a follow-on to Kepler. They're both exoplanet transit discovery missions. TESS finds transiting exoplanets around nearby bright stars. And we were also NASA's first mission to launch on a SpaceX Falcon 9. There's our SpaceX mission patch there. It was really fascinating to see the two cultures come together to launch this mission. SpaceX and NASA do things very differently, but of course, doing things together, a great experience, and certainly hopeful that I can bring some of that to Artemis. And TESS was a follow-on to Kepler, and Kepler was launched about 10 years earlier than that. And together, these missions have found thousands of exoplanet candidates and hundreds of confirmed exoplanets.
So what is great about the Artemis 3 team that we have now is that we bring together a lot of different expertise. If we go to the next slide, experiences, but with a shared vision of the future, which is all based on what we can get out of Artemis 3. And the foundation for the science in Artemis 3 is the science drivers, the community-led documents. Patty has done an excellent job of not only reviewing those, but of course, is the foundation of the science that we're going to do on the mission. And as was mentioned earlier today, the foundation of the science goals and objectives that we'll talk about here are these shared community documents. So, for all of the folks who are listening to here today who have contributed to any one or all of these publications, know that your hard work over the last several decades leads us to this point in time where we are, executing on the Artemis 3 mission, leveraging the science goals and objectives that have been defined for us by the community. Next slide, please. All right, so what is Artemis 3 science? A little bit of an update. So we are working towards a 2027 launch for the mission. The science complement for the mission has been defined through community solicitation. Of course, we have multiple phases of the mission. We're going to have obviously all of the work that's going to be done on the surface by crew, but also in orbit around the moon. As Kelsey talked about for Artemis 2, we'll leverage the experience for Artemis 2 in terms of orbital observations by the crew from the unique near rectilinear halo orbit. Try saying that 1 times fast, never mind 2 times fast, as well as a biological and physical sciences experiment that'll be carried in Orion. You'll hear a little bit more about that later on in this session. Today, we're going to talk about site selection. We're going to hear from the geology team. We're going to get an update on deployed instruments from Renee Weber, and we'll get some additional insight into biological physical sciences, some of the training that's going on to support crew and support the science team to be supporting the crew, as well as some more insight into what we can expect for sample return from the mission. Again, I encourage everyone to hold your questions either in the chat, in the online question tool, and then we'll use the Q&A session to get feedback from all of you wonderful people. But now is the time to ask your questions. Next slide, please. Payloads are marching forward at a rapid pace. You're going to hear more from Renee shortly. They are moving through the development cycle. They've undergone some testing. You'll hear more about that later on. As you've heard, Artemis 2 is going to be a great training opportunity for the Artemis 3 experience in terms of how we integrate into flight mission and how that works. So looking very much forward to the lessons learned from Artemis 2. And as you hear more about some of the recent tests that were participated in by members of the science team and a recovery at sea test in San Diego, as well as some deployed experiment tests in April at JSC, have given us great insight into how this mission is going to work. As a reminder, is that our goal for this mission is not just to do the sciences, but to get the science into the hands of the community. We're all very excited for the opportunity to be part of this. What gives me great joy, though, is to know that at some point in the not too distant future, we will have new lunar samples in the curation facility at JSC. We will have new lunar data from the surface in the hands of our community after the mission. This is why we're doing it, is to get the data into the hands of our community, turn and burn, and get new insights into our nearest neighbor in space. course, there's multiple avenues for science in the mission. I will be talking about the SMD science, but our colleagues in HRP, the Human Research Program, also will be doing some great science on the mission as well. There's a lot happening right now, and the entirety of the Artemis 3 science team is focused on the work at hand and putting us in the best position for success for the mission. And I'll reiterate that time and time again. Next slide, please. Okay, so as a reminder, Artemis 3 is going to be our first landed mission. Orion will get into the near rectilinear halo orbit. Will rendezvous with HLS. HLS will descend to the surface. We'll have up to 6.5 days on the lunar surface, and then they'll come home. And so the mission will be complex, no question, a lot of parts, a lot of moving parts. It's going to be very dynamic. And part of the complexity, as you'll hear in our landing site discussion after me here, is getting all of these pieces lined up together to execute a successful mission. And so if you ever are wondering, why is Artemis 3 so complicated? Well, it's because we are going to be doing things in a new way for the first time ever, and in order to do so, to get the science that we want. And so for all of these pieces to line up, we have to be patient, but we also have to know that, to get to this point, it's going to take a large team to do it, and a large team working together, and we are working together to the common goal. Next slide, please. So what are our science goals? Some of these will look familiar, but we pull them together. We're looking at early planetary evolution, the presence and distribution of volatiles throughout the solar system, regolith processes on airless bodies. What's the modern lunar environment as the moon cascades around the Earth, getting inundated by radiation and particles from the sun and from the galactic cosmic rays? We have experiments in Orion looking at microbiology of the environment that we're flying in, as well as human physiology. All of these are some of the main science thrusts of the mission. You'll hear more about the geology investigation and the various components that make up these goals for the mission. Next slide, please. We have multiple payloads that we're carrying with us. Again, Renee will talk specifically about them. We have 2 that are being built within a mile of where I'm sitting here, both LEMS and Allure being developed here at Goddard, LDA being developed with our colleagues at JAXA, LEAF, the collaboration with Space Lab and the science team there, and then MOBI, the BPS payload that you'll hear more about that's going to be flown on Orion. All of these, in addition to the surface activities, constitute the science thrust for Artemis 3, SMD science thrust for Artemis 3. Next slide, please. Of course, it wouldn't be a mission without a science traceability matrix. This is intended to show proof of life more than anything else, but all of the instruments come together, all of the geology objectives come together to create what I feel is a robust science package for the mission. Of course, this is the goals, the dreams, the hopes, the burdens of the mission is to meet all of these objectives, and we can just chunk through these slides one by one. You can advance now. That we have a lot that we want to do. It's a very science-filled mission. We are meeting objectives set out in multiple decadal surveys, not just the OWL. We have multiple objectives across all aspects of the mission, again, orbital and superficial. And so we are really going to be pushing the envelope on what we can do on the mission, finding every opportunity, next slide please, to get as much science in and out of the mission as possible. And again, ultimately into the hands of the community. Next slide, please. Next slide. And what makes me so encouraged by the mission is how it's a multitude of objectives. It's not just field sampling and not just instruments. It's all of them working together as one team, multiple teams coming together to form the science thrust for the mission. Next slide, please. And next slide. Okay, so let's go. We're going to be going to the moon in a couple of years. We are working very quickly. We have support, broad support, excellent support from ESDMD, and you heard from Jake earlier and Lori at the beginning of the session. We have great partnerships throughout the Moon to Mars mission program, and we're working as one team to pull this off. We are collectively, I'll speak on behalf of the entire science team, honored to represent this entire community for this endeavor. It's my goal that we make you all proud, and I cannot wait for the years of arguments over our data at future science conferences. We know that our team is moving quickly. We're going through multiple reviews, and we are going to fill every nook and cranny of the mission with as much science as we can. Again, please ask your questions. Now's the time for feedback for me, for Patty, and for the entire team. Next slide. And I think, I would just like to thank the community for their patience, their understanding, their encouragement, their words of support, and their criticisms, because without them, we don't refine ourselves, we don't get better. And with that, I have 5 seconds to spare. So I'd like to now pass the baton on to the next speaker,